From the dawn of humanity, the twinkling tapestry of the night sky has captivated our imaginations. The stars, like distant diamonds scattered across a velvet canvas, have beckoned us with their mystery. What secrets do they hold? What wonders lie hidden within their celestial embrace? The allure of space, with its promise of the unknown, has forever fueled our desire to explore the cosmos. We have always sought to understand our place in the grand scheme of the universe. Ancient civilizations wove intricate myths and legends around the celestial bodies, charting their movements and ascribing to them divine powers. Today, armed with the tools of science, we continue to probe the cosmos, driven by an insatiable curiosity to unravel the mysteries that lie beyond our world. Our journey of exploration begins with a single step, a line drawn not on the ground, but high above it. This boundary, known as the Kármán line, marks the threshold between our planet and the stark, unforgiving environment of space. As we venture beyond this line, we enter a realm unlike anything we experience on Earth. It is a place of extreme temperatures, where the familiar laws of physics seem to bend and twist. It is a silent realm, devoid of air and the comforting sounds of our world. Yet, it is within this alien environment that we find some of the most awe-inspiring wonders of the universe. The boundary between Earth and space is not a physical barrier, but rather a point where our atmosphere thins to the point where conventional flight becomes impossible. This boundary, known as the Kármán line, lies 100 kilometers or 62 miles above sea level. The Kármán line is named after Theodor von Kármán, a Hungarian-American physicist and engineer who was instrumental in the development of rocketry and astronautics. He determined that at this altitude, the air is so thin that an aircraft would have to travel faster than orbital velocity to generate enough lift to stay aloft. Crossing the Kármán line is a significant achievement, as it marks the transition from atmospheric flight to spaceflight. It is the point at which we truly leave behind the bounds of our planet and enter the realm of space. In space, sound, as we know it, cannot exist. Sound waves require a medium, such as air or water, to travel. They propagate through these mediums by causing vibrations in the molecules that make up the material. In the vast emptiness between stars and planets, there are simply not enough atoms close together to transmit sound waves. The few atoms that are present are spread incredibly thinly, making it impossible for them to interact in a way that would create sound. So, if a spaceship were to explode in the vacuum of space, there would be no deafening roar, no thunderous boom. The event would unfold in utter silence, a testament to the eerie quietude of the cosmos. Space is legendary, but it's not as straightforward as one might think. Space itself doesn't have a temperature in the conventional sense. Temperature is a measure of the average kinetic energy of the particles within a substance. In space, where there is very little matter, there are very few particles to measure. However, objects in space can experience extreme temperatures depending on their proximity to a star and whether they are exposed to direct sunlight. In the absence of an atmosphere to moderate temperatures, an object in direct sunlight can reach scorching temperatures, while the same object in shadow can plunge to frigid lows. For example, the surface of the moon, which has no atmosphere to speak of, can reach a scorching 250 degrees Fahrenheit or 121 degrees Celsius during the day, and a bone-chilling minus 208 degrees Fahrenheit or minus 123 degrees Celsius at night. This extreme temperature swing highlights the critical role that atmospheres play in regulating temperature and the challenges posed by the harsh environment of space. An empty canvas. The vacuum of space. Space is often described as a vacuum, but it is not entirely empty. It is a near-perfect vacuum, meaning that it contains very little matter. The vacuum of space is one of its most defining characteristics, shaping the way objects move and interact. On Earth, air resistance plays a significant role in the motion of objects. A ball thrown through the air will eventually slow down and fall to the ground due to friction with the air molecules. However, in the vacuum of space, there is no air resistance. Objects in motion will continue to travel in a straight line at a constant speed unless acted upon by an external force, a concept known as inertia. This lack of resistance is what allows spacecraft to travel vast distances without the need for constant propulsion. Between the galaxies, a sea of sparse atoms. While the vacuum of space is incredibly empty, it is not completely devoid of matter. Even in the vast gulfs between galaxies, there exists a sparse scattering of atoms known as the intergalactic medium. This intergalactic medium is incredibly tenuous, with an average density of less than 1 atom per cubic meter. To put that into perspective, a cubic meter of air at sea level on Earth contains roughly 2.5 times 10 to the power of 25 molecules, highlighting the extreme emptiness of intergalactic space. Despite its low density, the intergalactic medium plays a crucial role in the evolution of galaxies. It serves as a reservoir of gas that can fuel star formation and can also be affected by the powerful outflows of energy from active galactic nuclei. The Milky Way, our galactic home. Our solar system resides within a vast collection of stars, gas, and dust known as the Milky Way galaxy. The Milky Way is a barred spiral galaxy with a central bar-shaped structure and spiral arms that extend outwards. It is estimated to contain between 100 and 400 billion stars, making it a truly immense celestial city. Our Sun is just one of these stars, located roughly 26,000 light-years from the galactic center in a relatively quiet spiral arm known as the Orion Arm. The Milky Way is constantly rotating, with objects further from the center taking longer to complete an orbit. It takes our solar system roughly 230 million years to complete one orbit around the galactic center. The expanding universe, a journey through time. One of the most profound discoveries in the history of astronomy is that our universe is expanding. This expansion was first observed in the 1920s by astronomer Edwin Hubble, who noticed that distant galaxies were moving away from us. Furthermore, he found that the farther away a galaxy is, the faster it is receding from us. This observation led to the development of Hubble's law, which states that the recessional velocity of a galaxy is proportional to its distance from us. The expansion of the universe is not like the explosion of a bomb, where fragments are propelled outwards into pre-existing space. Instead, it is the fabric of space itself that is stretching, carrying galaxies along with it. This expansion has profound implications for our understanding of the universe's history and its ultimate fate. A universe of galaxies, countless islands in the cosmos. Our Milky Way is but one of billions of galaxies that populate the observable universe. Current estimates suggest that there are trillions of galaxies in the observable universe, each containing billions or even trillions of stars. Galaxies come in a variety of shapes and sizes, from majestic spirals like our own, to elliptical galaxies that resemble giant cosmic footballs. They are often found clustered together in groups or clusters, bound by their mutual gravitational attraction. The sheer number of galaxies in the universe is a testament to its vastness and the incredible diversity of objects that it contains. Each of these galaxies represents a potential island of stars, planets, and perhaps even life, making the universe a truly awe-inspiring place to explore. Outpost in orbit, the International Space Station. Since the early days of space exploration, humans have dreamed of establishing a permanent presence in space. The International Space Station, ISS, represents the culmination of this dream, a testament to international cooperation and the indomitable spirit of exploration. The ISS is a marvel of engineering, a modular space station that orbits Earth at an altitude of approximately 400 kilometers or 250 miles. It serves as a microgravity laboratory, a platform for Earth observation, and a stepping stone for future missions to the Moon, Mars, and beyond. Astronauts from around the world live and work aboard the ISS, conducting scientific experiments, testing new technologies, and inspiring future generations of explorers. The station stands as a symbol of humanity's ability to overcome challenges and achieve great things when we work together. Exploration beyond Earth, journeys to our celestial neighbors. Our exploration of space extends beyond Earth's orbit, reaching out to the planets, moons, and other celestial bodies that share our solar system. Robotic spacecraft have visited every planet in our solar system, beaming back stunning images and invaluable data that have revolutionized our understanding of these distant worlds. We have explored the towering volcanoes of Mars, the swirling clouds of Jupiter, and the icy rings of Saturn. We have landed probes on Venus, touched down on Titan, and even flown by Pluto, the distant dwarf planet at the edge of our solar system. These missions have revealed a solar system that is far more diverse and dynamic than we ever imagined. They have shown us that our planet is but one world among many, each with its own unique story to tell, and they have fueled our desire to push the boundaries of exploration even further, to seek out new discoveries and unravel the mysteries of the universe we inhabit.